Welcome to Cpp.chat, an algorithmic look at what's going on in the world of C++, chatting with guests from the community. Now, before we rotate in this week's guest, John has a disclaimer to read.
Thank you, Phil. The authors of this site are not engaged in rendering professional advice or services to the individual reader. The ideas, procedures, and suggestions contained within this work are not intended as a substitute for consulting with your physician. All matters regarding your health require medical supervision. The authors shall not be liable or responsible for any loss or damage allegedly arising from any information or suggestion from this website. You, as a reader of this website, are totally and completely responsible for your own health and health care. All right. So our guest this week is Connor. Is your mic on?
It is, yeah.
Oh, okay, great. All right. So you've playing with it. I go, oh no, something's wrong. No, Conor Hoekstra is our guest. And for those of you who aren't familiar with Conor, he has been doing talks on algorithms that have gotten a lot of attention. I know at Cpp Con and Cpp Now, but I think also you did. Where did you do?
Yeah, my first two conferences were C++ Now and Cpp Con in 2019. But then I also presented at I believe it was the ACCU Belfast conference that was right after the Belfast ISO meeting, and then at Meeting C++ and Code Dive as well in 2019.
Right. So you've become quite the conference star, right?
I would not say that, no. But I do enjoy speaking at conferences, and it's nice to interact with the community.
It is. It's a lot of fun, isn't it? That segues nicely into one piece of news that I wanted to bring up, which is that the call for submissions for Cpp Con, which is out and is good until June 5th, we are inviting people to make a comment in their submission. There's a comment field in the submission saying this is a virtual only submission. There is the possibility that Cpp Con will be canceled, and if it is, we will want to, I guess we shouldn't say cancel it. Instead, what we would say is we would be making it virtual. It's a completely different format, of course, but we'll be looking to the people who've made submissions, because there probably won't, when that decision's made, there probably won't be time to make a whole call for submission. So if you're interested in doing a virtual talk at Cpp Con, this is your opportunity. It may not ever happen again any other year. So if you'd love to give a conference talk and never actually make it to a conference because you can't travel for whatever reason, make your submission at Cpp Con, and in the comments say this is a submission for virtual or remote talk only.
That's a small move to be thinking ahead like that.
What's that?
I know from C++ on C, obviously we started off as a normal conference. When we decided we were going to move online, I then had to coordinate with all of the speakers we'd already accepted to say, who wants to continue in the online format, and how much are you committed to that, and so on, so we could build a virtual program.
Right.
So that's taken a bit of time and organizing, which will happen almost automatically if you're already allowing for that in your call for speakers.
Right. Well, we didn't quite have it that way. So if you don't say anything, we're going to assume that you're submitting only for the live version. And if and when we do go with the virtual version, we'll have to contact people, but we will already have evaluated their submissions. And so we'll just contact them and say, if you're willing to do a virtual version, then we have your submission already. So I think it will make things smoother. It's not as smooth as if we'd intended it from the beginning. We could have done it a little differently, but this is the situation we're at. So that's what we're doing. The other announcement, which is not really an announcement, it's kind of a pre-announcement, but I think we're going to open registration next week. It's going to be a different conference, and I haven't completed the announcement, but it's going to be very much scaled back. Part of that would have to be because I'm sure we'll get fewer attendees this year than, even if everything goes the most optimistically we can possibly imagine from this moment until September, we still wouldn't get as many people as we would originally anticipated. But there's other issues too, like spacing concerns and things like that. So it's going to be a scaled down conference, and we may in fact be in a situation where we could sell out. In other words, we've never been in that situation before because we've always planned for a huge group and we've always gotten a huge group and everything's great. This year, we're going to plan for a much smaller group, and it is actually possible that we'll sell out. So we'll cover that in the announcement. But anyway, that's the big announcement for Cpp Con, which is not yet an announcement. It's just a tease of an announcement. So anyway, is there anything else we want to talk about? I guess in the show notes, we wanted to say there is I think we've mentioned this before, there is a Reddit posting that's pinned. Normally in the CPP channel and Reddit, there's only one pinned announcement, and that is a jobs posting. But this year, there is an addition to that, or I should say currently, there is an addition to that, a pinned announcement tracking events that are canceled, moved online, or whatever the status is. You know, if you have been, for whatever reason, if you normally don't travel or something like that, and you've never been to a user group meeting, or if you've never been to a conference, now is your time, because you can go to user group meetings all over the world now, just as easy as clicking a mouse, right? So there's some silver linings to the, in addition to silver hair growing into your eyes, there's also silver lining.
So as well as that Reddit post, there's also Harold on the Sweden
Right.
CPP group. Forget the URL. I'll put it in the show notes.
Okay.
But he's tracking all of the meetups for C++ groups around the world that he knows of.
Right.
So you can just go to a single page and see everything that's upcoming. So that's a really great resource as well.
Yeah, and he's updating that. Jens has has his normal monthly update of meetups as well. So, but I think Harold is kind of monitoring this really closely. So that's good to have that kind of update as well. So that's great.
That's one thing I wish that Meetup would change, is that they don't show the correct time based on your time zone. So you have to do the translations yourself. And there's been a couple meetups that I've wanted to attend, but I've forgotten. And Meetup should get on that, because I don't know why they wouldn't just show you your local time.
Right. Well, of course, when the whole idea with Meetup was facilitating real world meetups. So of course they just assumed you're going to be local. And even if you're not local, you need to know the time so that when you fly there, you will be, So yeah, no, I understand why it's a whole new world and people are trying to still make adjustments to it. So
Time zones are hard.
Oh yeah. Time zones are very hard.
Before we move off of conferences and meetups, I should mention that C++ and C mentioned last time that it's moving online as well, of course. We now have new dates as well. So 15th to 17th of July. And there's a news post which goes into that and some other details as well. So I'll put that in the show notes as well.
Right. Also, I didn't see the details. I didn't have time to read the details. The email just came through. Herb is announcing that ISO meetings there's already some that had been, they never say they're canceled. They say they're postponed or moved forward till next year or whatever. But yeah, I think we've dropped a couple more live ISO meetings. And so you look on Herb's blog or look on iso.cpp.org to have the latest on isocpp.org. Always has the latest on what the schedule is for ISO meetings. So. All right. So let's start talking about, speaking of conference talks, do you have New York meeting is postponed? Renee just mentioned this on the Slack. Connor, do you have any talks that you're working on now? I think you did like a first version and then a second version kind of the same talk, just with the algorithms theme. Is that how it worked?
Yeah, so of the 5 conferences that I mentioned, the first 2 were the first talk that I gave, which was entitled Algorithm Intuition. I recommend the C++ Now version of that. I think because it was the very first time I was giving it, I was more excited.
I think the audience was probably excited too from the from the voting that followed.
Yeah, that was very surprising. And then the second sequel or follow up to that talk was Better Algorithm Intuition. It was originally, I was going to call it Algorithm Intuition 2, but I got feedback that that was just too confusing and too similar to the name of the first talk. But I still sort of had the same problem. A lot of people thought that the sequel to my talk was me just giving the same talk again. So there was those two talks. The first one focused more on the numeric header, and then the second one focused more on the algorithms header. Those are the ones that I've given in the past, and then I'm working on. I was working on a talk for the C++ Now 2020. That was what I'm calling the third talk in my algorithm intuition trilogy. I'm more excited about that talk than I have been about any talk that I've ever given, although I've only given, I think, 3 or 4 up to this point. And unfortunately, as I'm sure you know better than anybody, that's been canceled. But I'm going to hold on to that talk until next year. Because I think the audience and sort of the format is a little bit of a smaller venue, and you're interacting more with your audience. That's one of the big differences between C++ Now and Cpp Con. As a presenter, you are potentially in a much, much bigger room with order of magnitude more people in the audience. And I think with more people in the audience, less people are willing to sort of put their hand up and like have an interactive talk. And this talk is definitely one of those talks where I'd prefer it to be more interactive. So,
well, it's not just the size of the audience. A lot of it is expectation. Expectation at C++ Now is that a talk is going to be something of a dialogue. And I've said this a number of times, so people who've listened are probably bored of hearing me say this, but the expectation at Cpp Con is that the person at the front of the room is the most knowledgeable person on the topic. Whereas at C++ Now, I've given talks where I was talking about move semantics, and Howard Hinnett's in the audience, which, as I pointed out, that's kind of nice, because when you get a question, you can always say, yeah, Howard, how is that supposed to work now?
For sure. You see comments all that, because I watched so many C++ Now talks on YouTube before ever attending, and so many of the comments in like the really interactive talks are like people asking the audience members, who you can't hear as well depending on the room it was recorded in, to like stop asking questions, but they don't understand that that's sort of, it's very much encouraged. I think that's sort of being addressed. You added the throwable mic. So now we can throw around this mic and capture what the audience, and actually make that a part of the recording, which is awesome.
Well, so yeah, capturing it on the recording, but I think a lot of people it's kind of like what I was saying about the expectation is that the person at the front of the room is the one who has all the knowledge. And so the audience should just shut up and sit down so that we can hear what the person at the front is saying. And they just don't understand that, no, we got this audience together and we're going to get the most out of the audience we can. I remember seeing a discussion kind of like what you were saying in some of the comments. I think this was on Reddit and not actually on the YouTube, but there was a couple of people commenting about, yeah, those C++ Now videos are so hard to watch. And I thought they were making a comment. This was before we had Bash Films doing them professionally. So I thought they were going to make comments about sound quality and video quality, and, because it wasn't up to what we would expect of a professional. And so when I asked them about that, they said, no, it's just constantly being interrupted with questions. And I said, well, which sessions are you talking about? Well, it turns out they were talking about 2 sessions that I happen to have seen. And I think people, sometimes when I talk to people, they kind of assume I've been to all the sessions. It's like, well, that can't happen. In fact, of all the people at the conference, I'm probably the one most likely to miss sessions, right? So I don't go to as many as I'd like. But I happen to have seen both of the sessions they were talking about. And one of them was a Marshall Clough session. And I'd gone to that one. And the reason you go to a Marshall session is not just because he's going to give a great talk. In this case, it was a talk I'd actually seen him give before. And I went anyway. And the reason is Marshall gets the best audience. The audience is going to be there. And that's what you want. You want that give and take with the audience. And the other talk was a talk of Chandler's. And it was interesting because I'm delighted always to have Chandler talk at any conference that I'm working on. And I've had it several, but this was the one where he said to me at least 3 times, he says, I'm really nervous about this talk. It's like, why is Chandler so nervous? Chandler has a great delivery. He's very knowledgeable. He knows how to control the room. Why was he so nervous? But he told me, he said, this, by the way, was a few years ago. And what he had an idea was that ranges should have a certain feature. And he wanted to make certain that whatever came out of ranges supported to be able to do what he was wanting to demonstrate. And so he was proposing a ranges implementation that he knew himself was not the right long-term implementation, but it had some neat features that's what he was trying to show off. And that's why he was so nervous, because he knew that if people really start nailing on this implementation, it's not the right implementation. He knew that. That wasn't his point. His point was, look at these nice features. Let's see if we can get these features in the right implementation. So that's why he was nervous. But again, the reason there was so much give and take in the audience is because that's what he was asking for. That's what that was about. It's like, let's figure out how important these features are, how useful these features would be, and get that involved. So, so it's entirely a perception. These people watching the video were frustrated, and part of it is, there's a sound quality issue with the questions. There's no question about that. It's harder to capture that, but I think they'd kind of missed the point of what's different about C++ now from Cpp Con, and that is you've got a great audience there. A third of the audience are speakers. Probably 15 to 20% of the audience are standards committee members. It's just this incredibly rich audience, and you want those comments.
Yeah, one thing I'm sure a lot of people don't know about my original algorithm intuition talk at C++ Now is the whole last section that focuses on the algorithm intuition table was not a part of my original talk. That was all created while I was at C++ Now, and like whole slides were added due to conversations with people that I had at the conference. Like I remember explicitly talking with Ben Dean about how I had this example of generating Fibonacci numbers with the transform algorithm. And he's like, oh, you can do the same thing with adjacent difference. And I was like, no, of course not. Like you can't do that. That's not what adjacent difference is for. And he's like, no, you can do it. Like adjacent difference is very similar to transform, except it's instead of taking 2 arbitrary ranges, it's taking sort of the zip tail functional programming pattern. So like the first to second last element as your first range, and then your second to last element of the same range. So you have adjacent pairs. And then the difference is like hard coded into the name, which is one of the points I make in my talk, is like, it's a terrible name. Like the minus, std minus is the default operation. But like that should not be encoded into the name of the algorithm. Really, it should be something like adjacent transform. Yeah. And when he pointed that out, I thought about it for a second, and then I just had this eureka moment of like, holy smokes, like I would never in a million years have realized the relationship between adjacent difference and transform. First of all, they're in 2 completely different headers. One's in numeric, one's in algorithm. And I had only just started learning about functional programming in the previous year, and I knew about the zip tail trick. Anyways, so like the whole point is that like the talk got better just from being at the conference and talking to the people that were attending the conference. And yeah, people always talk about the hallway track, and it's impossible to hear someone say, oh, it's great being able to talk to people in between sessions until you actually go. Like I'd heard people say it on both CppCast and Cpp.chat, and it's like someone telling you about the Grand Canyon. You can't appreciate it until you actually see it. And you're like, oh, I understand now what people were talking about. Like when someone tells you, you're just like, it's just a hole in the ground. Like how great could it be? And then you go and you see it, and you're like, oh, this is not describable with words. I understand why people were trying to tell me it's important to go see.
Right. And you can't, I don't know how to say it. I mean, you can't be specific either. You can't say, oh, go and you'll get this one great insight on this one particular problem. It's not like that. Instead, it's like you were talking about, this connection that you had never even thought about that you were missing, right? You didn't know that was not there until Ben pointed out, and it's like, oh wow, yeah, and that's those are the kinds of discussions that happen. In your case, it helped a talk you were giving, but it could just as easily have been an important breakthrough in an application you were designing or some kind of library you're working on or something like that, where, oh wow, that's the thing. And you're exactly right. That's what we're trying to make happen, trying to facilitate. So how did the talk go? Did you get the discussion you wanted? I guess you must have, because you said you'd like to do your next one at C++ Now as well.
Yeah, no, I think you're always your worst critic. So afterwards, I knew that there was like 3 or 4 places in the talk that like I hadn't executed the way that I had planned it in my head. So like I was focusing on those things. And I think that's true for like a lot of people who give talks. Right afterwards, all you're thinking about is like, oh, I fumbled my words at that one point. Or, when I answered that question, I didn't answer it as eloquently as I would have liked to, or as coherently as I would have liked to. So I think right after the talk, I was sort of relieved, and you're done, and you're working up to it, the whole week and the week leading up to it. So I was happy to be done, and I was thinking that there was these things I could have done better. But there was a ton of people that afterwards they came up and approached me and were like super excited about what I had talked about, and wanted to share their sort of like experiences that they had had. I remember there was one individual that came up and was telling me that the scan algorithm they use in their interviews all the time, and there's this whole world of like prefix sums is what they're referred to sometimes. And he was explaining to me this one application that was really, really cool. Anyway, so having that kind of feedback is just fantastic. And I've had that mostly for each of the talks. Like everyone's when you're excited about something and there's someone else in the room that's excited about the same thing, and they find out that you're excited and they just want to talk to you about it, like it's so awesome. Like I could talk about algorithms. I think I can't remember if it was in a tweet I saw once, but that like, Bending, it might've been his partner that tweeted it, was talking about just staring off into space and was just like dreaming about algorithms or something. And his partner asked, what are you doing? And he's, I'm thinking about stable sort or something like that, or stable partition, or something like that. And I feel the same way. As there's a lot of times I'll be thinking about one specific algorithm, and how come it's not designed slightly differently so I could do this with that. And so
or why isn't it named slightly differently?
Yeah. And so the feedback was awesome, and then I was a bit surprised towards the end of the conference when my name got mentioned a few times, and at that point I think I realized that it went better than I had thought.
Well, this is universal. I have spoken with an awful lot of people who've just given a talk, and I know they all are thinking the same things, which is, first of all, they think it could have gone better. They're, as you said, they're their worst critics. They think of instead of all the points that went well, they think of the 2 issues that they didn't word the way they wish they had. And the second thing is they're glad it's over. It's like, oh, it's done. Now I can concentrate on the conference, or for some of them, now I can concentrate on my next talk.
Yeah.
There are certain people who I've learned, oh, you really want to schedule them on Monday, otherwise you won't see them in the conference.
Yes.
I forgot you were here. Where have you been? Oh, I've been in my room doing the notes on my talk. So I was like, oh yeah.
Yeah, they keep scheduling me on Saturday at the ACCU conference.
So yes, yeah. And the person I had in mind is in the chat room, and he recognized himself.
We won't mention Michael Casey's name on air.
Yeah, we wouldn't mention Michael's name because it might embarrass him. But oh yeah. All right. So so you said 5 different conferences you've spoken at now.
Well, I said 5, and then immediately someone in the chat, Michael Case, pointed out that technically I also spoke, quote unquote, because it was an online conference where you just recorded it locally and uploaded it. I had a talk at PyCon 2020, which is really, I'm sad that all conferences are delayed, but obviously it's the right decision and it has to be done. But I was really looking forward to interacting with the Python community, because anyone that's seen my talks knows that I think in my very first talk I said on my About Me slide, I said I'm interested in programming languages, and then 2 or 3 talks later I had upgraded that to I'm a programming language enthusiast. And I'm considering upgrading that to something that I heard someone who was a Smalltalk developer. He referred to himself as a Smalltalk addict. And I sort of like that. And so I might start referring to myself as a programming language addict. And so I'm always learning several languages. I've referred to sort of Haskell a lot in my talk so far. Anyway, so I happened to be doing something for work, and I ended up refactoring this code that I had gotten off a blog post. And it wasn't, I don't think, anything revolutionary that I was doing, but while I was doing it, I ended up taking like 60 lines of code and refactoring it down to 10, and then realizing that there's actually just a library that I could use, like one call to a specific function that does exactly what these 60 lines of code does. And so it's I think some of the techniques I showed are pretty simple, but like when I was a junior developer, I was writing the code that looked like the original 60 lines because I had not seen these techniques. At some point when you're starting out, you just don't know the abstractions or the algorithms or the functions. And so it was aimed to be a beginner talk that just showed, here are a few very simple things that you're going to see all the time, because it's before you know.
So that's what your talk was, where you said, this is what I started with. I rewrote it to this, and then I recognized I could have done this.
Yeah. So it was a talk called Beautiful Python Refactoring, and it was just a 30-minute talk that, it's the whole point is just, here's 8 different tricks or not tricks, but just sort of refactorings. Like one of them is whenever you see an index I set to 0 outside a for loop, and then inside the for loop, either at the beginning or the end, you're doing an increment. So every iteration of the for loop, you're basically incrementing your index, because in Python, they don't have index-based for loops by default. They have like the equivalent of our range-based for loops. So you'll have like for, value in list. And you can get an index-based for loop if you do for I in like the range of length of your list, but most people don't want to do that. But there's a function in Python called enumerate, which we may or may not get with ranges at some point in the future. But basically it bundles your elements in your list or your structure, or your sequence that you're looping over into a tuple or a pair. And the first element is the index that is corresponding to that element, and the second one is your element. So in Python, they have baked into the language destructuring, or iterable unpacking, as they call it. It's the same as C++17 structure bindings, where you can basically destructure the elements of a tuple or pair. And so it's just a very nice, instead of setting a variable I outside your loop and then incrementing it, you can just, in one line in your for loop, go for, I comma elements in enumerate of whatever sequence you're looping through. And twice in the code that I was refactoring, this came up. And I see it all the time. You even see it in sometimes in C++ code. And we don't have enumerate per se, but there are ways also to get around that, or at least baked into the standard library. I'm sure Boost has it somewhere.
Yeah, I need that all the time in C++ as well. And occasionally I write my own, but it's non-trivial to get that right. It'd be nice to have that in the standard.
Yeah, other languages call it zip index or zip with index. I personally like zip with index the best. That's, I believe, what Scala calls it. But I think most people know it by enumerate. So my guess is that's what will end up getting named in C++ if we get it.
I'd be happy with just zip, and then you can put an iota in there.
Yeah. Well, if we got zip, you could very easily write it yourself, right?
So do you have this talk is up? It looks like in the chat you have at least one fan who's seen it.
Yeah.
I won't mention Michael Casey's name again.
Yeah.
I can post a link afterwards in the Slack to it. Yeah, it's in Python, but I do think it's in general sort of a language agnostic. Although there are some things specific to Python, like list comprehensions you don't have in every language, which is really nice. A really nice feature in Python that it should be utilized more, in my opinion. Yeah.
So I actually use Python quite a bit, and it really is weird because my relationship to Python is so different than my relationship to C++. I actually like them both and I enjoy them both, but in C++ I kind of feel like I understand everything I'm looking at, whereas in Python it's like, I think I know what this is doing. And there's a lot of Stack Overflow. Whereas in C++, occasionally we'll look on Stack Overflow. Most of the time my C++ on Stack Overflow is I'm looking for good questions to answer instead of looking for good answers for my questions. But not so in Python. I don't usually tell people how to do things in Python. I'm usually on the other end of that. But I enjoy Python a lot.
Yeah, Python's a fantastic language for getting things done. Not that I don't want to say C++ is not a fantastic language for getting things done, but there's been so many times where I've been trying to write like a bash script where I'm biting off more than I can chew. And then I'm just like, yeah, let's just see if we can do this in Python. And like, I've been spending like 30 to 60 minutes on the bash script. And then in less than 5 minutes, I'm done it in Python. Python just for productivity. I'm not sure that there's a better language out there.
I was going to ask you, actually, what is your favorite language that you've encountered so far?
Ooh, so if you had asked me a year or two ago, I would have said C++. And so I should qualify this. I'll give you probably my top 5. I should qualify this by saying like none of these languages have I really written production code in. I've written production code in Java, Python, and C++. But like all of my favorite languages are languages that I don't write production code in. So
there may be a reason for that.
Yeah, probably if I had to write production code in them, it would change my view on them. So that's my qualifier. But right now, probably number 1 is APL. Number 2 is probably Haskell. Number 3 is Racket. Number 4 is Clojure. And then number 5, I might say is C++.
Well, you know what Bjarne says? He says there's 2 kinds of languages. Yeah. There's the ones that people don't complain about, and the ones that people use to get real work done. So
yeah,
that's a paraphrase, something like that.
I'm sure if I were given the task of implementing a non-trivial application in all 5 of those languages, I would be done the fastest in C++, and probably it would be, not probably, almost definitely, it would be more performant than any of the other languages. And up to a certain point, I probably would be enjoying myself more in C++ just because I'd know what I was doing for sure. Whereas the other one,
and part of that is due to the nature of the language and the design and all that kind of stuff, that what the goals of the language were. But part of it also is there's a huge amount of tooling and support and things like that. So when you talk about, oh, this is a real world application, meaning, I don't get to pick what the hardware is going to be. It has to be able to run in this, and all these kinds of constraints. And suddenly you realize, oh, there's only one compiler to choose from, or some of these other constraints. It's not as easy to get real work done, real professional productivity done when you don't have all the tools. You don't have as great a community of libraries, or I should say a selection of libraries, ecosystem of libraries, and things like that. Those make a lot of difference.
Yeah, I just watched a talk last night called "The Sociology of Programming Languages," which was a talk from Strange Loop 2014, I believe. That was someone recommended it to me in a Clojure meetup that I was in last night. And in that talk, they did a survey on like what makes people choose a language for whether that's a personal project or something at work, if you have to choose a language, what's the language that you choose to get that done? And the number one thing was libraries. Like, what libraries do you have access to? And then like number 2, 3, and 4 all had to do with like the team's experience, or like the current code base or the current ecosystem that you're working with. I think the speaker was trying to make a point about, like, people care about performance, they care about safety, and I think there was a third thing, but like none of those 3 things that he would have expected to be at the top of the list on like, why do you choose a language, were there. Like for real world stuff, people are basing their decision on not sort of like the high level properties of the language. It's what do I have access to, and like what do the people around me know how to code with, which I thought was interesting.
Well, it's kind of a domain thing, right? I mean, in other words, you're going to do something that's going to be on the web. You're going to pick a language that has tons and tons of libraries focused on, it's what are people already using for that? Because that's where the libraries are going to be. Mm-hmm. And so it's a little bit self-reinforcing, because then you're also going to have, that's what people that you can hire or that are already working at your company, that's what they're going to know, and those kinds of things. But yeah, no, I completely understand that. And that's one of the things about Python that's pretty cool, is there's a great ecosystem of modules that you can download and use.
Yeah, there's one of the, wow, it makes me so jealous of other languages. It was both in Racket and in Rust. So last week, Jason Turner and his cousin Jonathan Turner did a 3-hour live stream of Rust programmer teaches C++ programmer Rust, which was, it was so fantastic. I wish there was people from every community doing this. They like Jason, who is, I assume almost everyone listening to this knows, but for those that you don't, he's the co-host of the rival podcast, Cpp Cast.
Bitter rivals, yes.
The others.
I like to say rival to cause drama. But so he had basically opened up like a whole new, I'm not sure if it was like a VirtualBox instance, but just like a fresh Linux. I think he was using Manjaro, and like he just started from scratch. So like you could do the same thing on your local box and just follow along. And when they went to start like a new package, they just did like, I can't remember what the command was, but it was like a single command line, and then it initialized like all the different files that you needed. It initialized like git init for you, and it already had like a hello world example in like the main Rust file. And if you do the same thing with Racket, they have almost the exact same command where you just go raco, like RACO, package new, name your package, and then you're off to the races. Like they already initialize your documentation files. And I don't work a lot with Conan or VC package. Like, I'm not sure if they have like a Conan new package where they generate all that stuff from scratch. But just like, as someone who knows nothing about Rust and Racket, and I want to go create a library, I was able to like get up and running in like no time at all. And like C++, at least as far as I know, does not have that story. And I am waiting and praying for the day that we have something similar. It does seem like over the years that we are starting to get some convergence on package managers. And I know the ISO committee is working on a technical report that's going to give guidance. And so hopefully in 5 years or so, we're going to have a really good story for that, where someone who's new to C++ can just go, Conan or VC package or whatever it is, new, name your package, and then with a couple command lines, just be off to the races.
Yeah. Part of the problem is there's just a bewildering set of choices about, because unlike other languages, we don't even say, what extensions your files have to have. I mean, we have a bunch of, conventions, but they're not that strictly held, right? You can have a CPP file, or you could actually, on some platforms, you could actually say C++. If your file system deals with that, it's fine. And that's what you name your files, or no extension at all. I mean, all these things can work. We put almost no constraints on you. Where's your documentation live? What does your documentation look like, right? Whereas other languages kind of have this whole culture of this is what your project's going to look like. This is where your folders are going to be. This is what your file names are going to be, all that kind of stuff. And so that's, in a sense, nobody wants to be the person who's going to restrict and say, well, you can't do it that way, you have to do it this way. But if you don't do that, it's kind of like,
I think there's like, I completely agree, but like there's something to be said about like how popular Godbolt has become. And like a lot of people use it for like looking at assembly and what does this actually compile down to. And I know a ton of people, including myself, where like if I really quickly just want to code some example to see why isn't this compiling, like you can use Godbolt as like a REPL environment almost, like in languages where you're just sort of building up by composing small statements together one by one to get ultimately what you want. You can sort of do the same thing with Godbolt, because every single time you stop typing, it starts compiling. And like, I think there's more to Godbolt than just looking at assembly. And it's because it's so easy to just get started. And then if you want to share something with someone, you do a share link and poof, someone's looking at the code you're looking at. Like, I think there's going to be a space for people that care less about those sort of fringe options at the beginning, that just want to be able to create like a new library and have it uploaded somewhere. Maybe I'm wrong, but I guess time will tell. And
no, that's fine for libraries. But what I would like to see is something where, I don't know what to say, some kind of out of the box where you say, oh yeah, I want to set up a new project, and it just checks. Okay, I want this version of Boost, and I want this. And, oh, I need continuous integration with this, and I'm going to use Catch, or I'm going to use Google Test, or whatever, and you just boom, 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 and then it's there and done. Part of that is I'm being spoiled, because in my career, I was always on a team big enough that there was somebody whose job it was to do build stuff, and that was never me. And that's what's lovely. It's kind of like, well, how do we do this? Oh, you just do this in the build option. Okay, that's all I want to know. Thanks. Somebody else already did that for me. And I don't want to do that stuff myself. And I'm no good at that stuff, but that's what, and that's what Vector Boole is talking about, project layouts. Very good.
I saw a tweet from someone recently that said something, and then the follow-up was trying really hard not to become the build guy.
I have ended up being the build guy in the past.
Yeah.
It's not fun.
It's underappreciated work, I think. And it's a lot of times, if you're not the build guy as your day job, you can end up banging your head against the wall because you don't know what's wrong.
Yeah. Anything that is computer operations is essentially this. People take it for granted when you make it work, and when it's not working, then staring daggers of evil at you. When I was at a big company doing support very early in my career, before I was a full-time programmer, I was doing support. And so I was writing kind of small apps, and I did have one individual who was the perfect client. Because I would say, well, how's everything going? Oh, it's great. This is wonderful. It's saving me so much time. This is so wonderful. And so I'd say, well, I was wondering, would it be helpful if we did this? He's, you could do that? He was the perfect client. He was so appreciative. Every little thing was wonderful. Never had a complaint. Even when it wasn't working, it was like, well, it's really great except this one little thing. And I was wondering, oh my gosh, what happened? Let's fix that. Yeah, he was great. But no, that's not the way it normally is. It's like, wait a minute, my build is taking 2.5 seconds longer than it used to take. What have you screwed up?
Yep.
So we know that C++ is lacking in build systems and package managers, but in terms of the language itself, what do you miss the most from other languages that you've used?
Well, my number one language feature or facility that I've fallen in love with, or I'm not sure if I can choose one, but one of the top ones is more a terse Lambda syntax. So Haskell has lambdas. Almost every language these days, even if it's not functional, has lambdas, or they might call them blocks or anonymous functions. There's several different names for these, or function literals, as Go calls them. But they're all the same thing, basically. Haskell, on top of lambdas, has something called sections, where basically you can specify parentheses, and then inside that parentheses, you can put an operator. So in 3 characters, you can basically go left paren plus right paren, and that is the equivalent of our binary stud : plus. And you can change that into a unary operation that is just add 1 by adding a 1 either to the left hand or to the right hand of that plus operator. So in 4 characters, you can define basically the equivalent of a lambda that adds 1 and is a unary operation. And in 3 characters, you can basically have a binary operator. And you can do that with multiplies, divides. You can do it with other functions as well. So it's this incredibly concise syntax. And some people will say that's just sugar. In my head, my response to that is always, well, I really like sugar. And also too, like, I think it doesn't fully, like, calling something sugar is very dismissive. Like, a lot of times, like, a lot of features are just sugar, like structure.
All of lambdas are just sugar. That's an amazingly powerful feature, and it's just sugar.
Yeah. So many things
can do that
are just
yourself.
sugar. Structured bindings, technically just sugar. And I think so much of this quote unquote features that are sugar leads to just like so much more readable and beautiful code. And so in C++, like I made a video and never uploaded it once called 10 lambdas in 10 languages. And I didn't end up posting it because I realized I wasn't knowledgeable enough in the other languages to know, like, if I was actually doing this the idiomatic way. So I still have that one, and I'll re-record it at some point. But like, going through that process made me so incredibly sad, because C++ is by far like the most verbose of all the languages. And that's because of legacy. But if there was some way to make that happen in C++,
there's something else. One of the things that Bjarne has pointed out is that when something new is introduced in the language, people, and he's pointed this out about the committee, but people get really conservative. This is this new thing. We need to have a lot of syntax to warn people, oh, you're doing a new thing. Kind of like, oh, templates have to be really heavyweight because templates are a new thing. And that's scary. And then as people get used to it, it's like, there's a whole lot of syntax here. Why do we need this much syntax? Why can't we just write this? And he says this is being repeated over and over again with every time we introduce a new feature, like concepts or something like that. At first it's scary, and then eventually it's like, well, why can't we just say it? Why can't we just write this and have that work, right? Mm-hmm. Having auto parameters, which is a shortcut of being templates, and those are the kinds of things that I remember. Before C++ 11 shipped, that was one of the things Bjarne said. He wanted to be able to just say, here's my function, and the parameters A and B are auto, and have that be synonymous or another way of expressing a template. He says, I don't think the committee will let me have that. But now we're there. Yeah. And I think that there's probably some insight to that. At first these things do look scary, and there's a million people who are using this programming language on a regular basis. You don't want to slip something at them that they don't see coming. But on the other hand, we do live forever with the conservative nature of what the way we introduce it. Sometimes we, the whole, basically the difference between lambdas in C++ 11 and lambdas in 14 are, okay, we were too conservative at specifying that. Here's a little bit more, here's a relaxed specification where you can do this and you can do this. And certainly we're going down the same thing with const expr. Const expr functions now can do so much more than they used to be able to do. Mm-hmm. And part of that is a good kind of conservatism, but to the extent that the syntax could be relaxed, that's what Bjarne was arguing for. And it's also kind of what you're saying, which is, look, I mean, I think if you introduce something like, parent plus parent, even I'd be freaked out. But
yeah, there's no way that's going to make it into C++. But in terms of what I'm jealous of another language is so that's one. The second one that is something we're sort of getting is a DSL basically for composable algorithms. So I should qualify too, because I've said this in multiple talks now that like the current algorithms in the algorithm and numeric header are not composable. And then very sadly, Sean Parent, my hero, in a Cpp.chat episode, nonetheless, which was, I believe it was one of the ones recorded at the Cpp Con 2019, made the comment that there's all these people saying that algorithms aren't composable, and that's hogwash. And so I should clarify and qualify that when I say composable, I don't actually mean lazy. What I really mean is pipeable. Like, yes. I want one algorithm where I can compose it with another algorithm where the output of the previous algorithm is the input of the next algorithm that I am piping it with. And the problem is that every language sort of calls this something different. In Lisp dialects, in both Racket and Clojure more recently, in Clojure they call them thrush operators, and more generically it's referred to as the threading macro. And it enables just the most beautiful, calling one algorithm and then the output is the next, the input to the next algorithm. And using threading macros, you can actually, one of the big complaints about Lisp dialects is you end up with all this nested expressions with parentheses, and it's incredibly hard to parse. Using the threading macro, you can get something very similar to what's coming with C++20 ranges and what you might see in a sort of other functional language like Haskell. And that's the thing, is a lot of languages have something called a pipeline operator or a pipe operator. And so those languages refer to it as sort of piping, but then there's other languages like Haskell that don't technically have a quote unquote, pipe or pipeline operator. They just have a composition operator. And so depending on the language or the ecosystem you're operating in, these are referred to different things. I haven't made up my mind of what we should refer to this as, because I think I think to a certain extent, Sean Parent is exactly correct in what he was saying, that these algorithms were designed to work together and they all basically build up to, I believe it's stable sort. Right. And that, rotate fits in here, and, this algorithm fits in here, and you take one out, and the whole thing falls apart because they all compose together. So in that regard, I completely agree. The current algorithms in C++ are composable, but they are not pipeable.
They're not functionally composable. Exactly.
And that is it's my favorite pattern to code in.
This was effectively I referenced earlier about Chandler giving a talk on ranges, and that was really the feature that he was trying to argue, is that somehow we need to have this pipeability feature. But I do remember, because I got to sit in on a series of classes that Alex Stepanoff gave, and I remember when I realized, oh my God, all these algorithms just build up the stable sort. I didn't realize these, it just seemed like this kind of set of algorithms. But when you realize, oh no, wait, that's because this is actually calling this is, oh yeah, they just assemble into stable sort. And in that sense, they're certainly composable. But in the sense that you're talking about, I spent some time doing something that I know you've spent serious time with, which is doing essentially, I don't know what you call it, competitive programming kind of stuff.
Oh yeah.
But I didn't do it competitively. I just went to one of those websites and it was like, okay, work this problem. And these problems were all pretty simple because the idea was to see how quickly you could do them. But I set a different goal for myself, which is I'm going to write this without any for loops. I'm only going to use either standard algorithms, or I'll write a new algorithm myself that has a for loop in it. But everything, and so rather than making it quick, I actually spent a lot of time on each project. But because the goal wasn't to do it as quickly as possible, the goal was to do it as cleanly as possible. And one of the things, of course, I wanted to do was not copy anything. But so many times it's like, okay, I guess I'm going to have to dump that into a vector so that I can apply the next thing to it. And what I really wanted to do was to be able to read this out of the file and make these transformations, a whole bunch of different transformations without ever having to say, okay, I guess I have to dump it into a vector here so that I can turn around and modify it in the vector. That's what I wanted to do. And wishing I had ranges to do that stuff.
There's I can't recommend like what you've just described. I did it both competitively and sort of just on my own. But there is like, I don't want to call it like a crisis. But if you go to like, so LeetCode is one of the most popular sites for this these days, that a lot of students in university, it's known as both a weekly competitive programming site, but also as like a interview prep site for big companies that a lot of people want to work at. And there was a question recently in one of the contests that I believe boiled down to, you have a vector of ones and zeros. Can you return true or false? True if you can guarantee that the distance between each of the ones has at least k zeros. So if you have, for instance, like 1, 0, 0, 0, 1, 0, 0, 1. So there's 3 ones, and the first and second are separated by 3 zeros, and the second one is separated by 2 zeros. If k is equal to 2, you would return true because you know that at least the ones are separated by at least 2 zeros. But if k is equal to 3 or anything greater than that, you have to return false. So you can solve this using one of my favorite algorithms, which we don't have in C++ yet. It's known by many different things. In D language, I believe they got the name right, called chunk by. It's called group by, or there's an algorithm similar to it in the range v3 library. But basically, you look at adjacent elements and you pass it a predicate, and then it's an anamorphic algorithm. So it's the opposite of a catamorphic algorithm. Catamorphic being it's a reduction. So it's typically, these are called like reduces or folds. And an anamorphic is called something that's an unfold. So it's like a split where you're taking a list and splitting it into multiple lists. So if you split up your list into sublists, when you have adjacent equal elements, you'll end up with a list of lists of just the ones and the zeros. And then you can do a simple map to length, filter out the ones, and then just check, do all the sublists that are just zeros, is the length of those all greater than or equal to whatever your k value is? So like in 4 or 3 algorithms composed together, you can very quickly solve this. Out of 150 solutions that were posted on the forum, mine is dead last. It's the very last one. And if you look at the top 10 or 20 solutions, they're all just these 20, 30, 40 line solutions that are all hand rolling this sort of comparing adjacent elements and then doing all these 4 different steps that you could easily compose together with different algorithms, like all in one big loop, which some people.
So wait a minute. How is yours ranked dead last? By popularity?
By popularity. So I think it's a stable sort by first based on the number of upvotes. Mine has 0. Potentially it has negative. I'm not sure. And then I think the second ranking is by number of views. So if you don't, it's sort of a bit biased. Same thing with like Reddit. If you don't get any upvotes early, it'll get pushed down to the second or third page, and then no one's ever going to view it. So it's based on a couple of things, but yeah, last time I checked, it was the least popular of all the solutions, and it makes me very sad that there's all these students in university that are learning for loops and if statements, and they're not learning how to compose algorithms, and they're not learning their algorithms. No one's listening to Sean. I don't think there's many professors that are talking about Sean Parent's, know all your algorithms, or that it's not just even Sean now. There's tons of people out there that are talking about how you need to learn your algorithms.
Jonathan Bacora is one.
Yeah, Kate Gregory, Odin Holmes, Michael Case has a talk that mentions that as well. And it's a shame.
But I thought I wondered where you were going with that, because you said you didn't recommend it, and for my purpose it was fine, because I don't think I even made my results. I don't even know what side I was on. So I don't know if anybody else looked at it. For me, it was just the challenge of, here's some little problem, and see how cleanly you can write this. And I wouldn't subject it to other people's comments, because if they vote you as the bottom, then I don't really care what their comments would be.
Leslie in the chat is suggesting that we give a link to Conor's solution, and we'll all upvote. So I'll put that in the show notes.
That's right. We all log in. And it's like, where did this thing come from?
It's less that I'm not offended personally that my solution is ranked so low. I'm more like, I want there to be more programmers in the world.
No, I completely understand.
Aware, yeah.
It's the same. It's the same as I feel. It's not that I'm afraid of what people are thinking. It's that I don't care of their opinion.
And I'm lucky now to work. I work on a team at NVIDIA, and our team is completely pro algorithms. Whenever there's a for loop in the code, we're always in code review asking, can this be an algorithm? And that, like, it makes me so happy, because whenever I'm able to replace a for loop with an algorithm, like I get like a dopamine hit. Like it's fantastic. And I've worked on teams in the past at other companies that are the complete opposite. Like they frown upon using algorithms because the culture there is just that a for loop is better. More people, everyone knows what a for loop is, and you can understand what it does, but not everybody knows what partition does. And that's going to cause overhead in terms of educating the company. And so I think by promoting like this style, more and more other teams and other companies are going to start to adopt this. And I don't think every company, like if there are people that really do prefer for loops, like that's not necessarily a bad thing.
Yes, it is.
Yes, it is. Okay, never.
Well, part of it is the mentality of just what you said. It's like, oh, we don't want people to learn about algorithms or have to spend any time looking things up or read documentation. We want to write a bunch of code that we then have to document and test ourselves, except we're not going to do a good job of either documenting or testing it, but we'll feel proud that it was invented here. I heard about a guy who worked at a company that had their own term for not invented here.
Yeah. Yeah, comments are always dangerous. Like I just did a refactoring on my day job, and they had these 3 Boolean parameters back to back in an API of a function, which is something that it drives me up the wall. And our team tries to reduce that and use either scoped enumerators or something that's more readable. And sure enough, in one of it started out as just a refactoring. But in one of the call sites, someone had put comments next to the 3 falses of what each one did, but had messed up the order. So it's just a comment, so it doesn't mean anything. But if you're reading that comment thinking, oh, I need to turn this to true, you're potentially going to get that wrong. And then another case I found where all of the last 5 parameters of the function had defaults. And the one of the calls was only passing the last 2, but they actually missed out the first 3 defaulted arguments, but due to implicit conversions to bool, it still compiled. And when I refactored that, I was like, oh, this is actually a bug. So yeah, comments are not always, they don't stand the test of time.
I worked with a woman that was her pet peeve too. And I was delighted one day when I went to her, and because I'd found in our code base, there was a function that took 4 true Boolean parameters, and 3 of them had defaults. And so, yeah, it was impossible to know what you were passing with any confidence. It was, that
Actually,
was her.
C-line can help there, because now it shows the names of the parameters next to them in the code.
I can't wait.
What would really help is to refactor them into enums.
Preaching to be converted. We are actually in danger. Well, we have iterated off the end of the hour.
Oh no!
Which is not particularly safe coding. So,
so we need to correct that by wishing everyone safe coding. It's been great having you on, Connor. We could only have talked for another couple hours. So,
No, thanks for having me on. This has been fun, and I'm looking forward to when COVID ends and conferences and communities are meeting up again.
Yeah. All right. Well, let's all wish our audience then safe coding until next time. So everyone, safe coding.
Safe coding.